Now we're going to build our Q table reinforcement learning algorithm from scratch. And before that, we have to build our environment. So to build our environment, we start as usual by open a Jupyter notebook, and we can rename it to be RL main or RL Q table main. And as always, we have to import the needed libraries. So we start by numpy as np, import a matplotlib.pyplot as plt in case we wanted to graph things. Of course, in this case, we will not really graph, but in case we wanted, we just import it from gem, actually. From gem, import environment. And what we need to understand here in gem is it's a library that has many environments and a method to identify these environments. Usually this way of identifying environments or defining environments is kind of standard, and it's easy to input this environment in multiple computation libraries such as OpenAI baseline 3 that we will use later in these lectures. We also can use it as an input for a deep neural network. We will also do that. So it's better to always define our environment as using gem. For example, if you also have different environments in gem. So if we go here and we Google basically OpenAI gem, and we can go to documentation, we can find many environments that we can use, just plug and play into our systems. So for example, we have Atari environments that, rather than, of course, you have to code your you try to connect the actual game with Python. You can just use these already made Atari games, and you can of course you can play it, but the main reason we want it is we want to make the computer play it. So it's very useful. So here you can see Atari. You can see also some robotics. It's like you want to control a robot to do a specific thing, so you can do that as well. So you have all these physical and also the actual robot motion environments. Another games we have here, and control problems. Maybe as engineers, this is also a very interesting thing for us. So how you control, for example, carpool to be straightforward, or you want a mountain car to get to the flag here. So all of these are many environments that we want, that we can use. But in our case, we don't want to use already made environment. What we want is we want to build our environment, and of course construct our Q table reinforcement algorithm code from scratch. So this is what we are interested in. But of course you can do it. You can use these environments and plug it to even this algorithm, or of course just with another solver. So from here, from gem, which we already talked about, we import environment, and also from gem dot spaces, we import the spaces we will use, which is discrete and box, and the difference between them is now we want to define the spaces of or action spaces, and of course observation spaces or state spaces. So the action space in our case will be only 3 actions. Why? Because the problem we're trying to solve, we will have in our case we will have 3 actions. I will explain the problem in just a minute. For so when you have taking a very specific actions, that is increase a specific number or decrease a specific number or keep it the same, or if you're playing Atari, you will go Atari games, you will go from I want to go to left, I want to go to right, and so on. So this is also another very discrete kind of actions, specific actions you have. Now the box, in the other hand, is if you want to have your state to be continuous. That is, the temperature might be 0, the temperature might be 2, the temperature might be 3, the temperature might be 2.5. It's continuous, that has basically any space that you want to have it as a continuous, but you have upper and lower limit for it. So this is always this is why we use here box. So in our case we will use box for states and discrete for actions. Just one final thing, we import also the random, and random is just the same as we did before, just to generate any random number. So now we can see that we have all these libraries important. And now let's talk about our problem. So our problem, what we will code here, is a very simple one. We have a room, and the room will have to have the temperature to be in between 24 and 26. So we will make we have a room, and we need to control the room between 24 and 26. If the temperature become more than 26, so become 27, 28, 30, and so on, the controller has to decrease the temperature, and he cannot decrease it one fold. He has to decrease by one value. So if the temperature is 30, he needs to decrease it to 29, and next step he will need to like after 1 second, let's say, he decrease it from 29 to 28, 27, until he gets to 26, and it's good. If the temperature is 20, again, if the temperature is 23, that's too low. He needs to increase the temperature to 24. So it's a very simple thing. We have a controller to control a room to be from 26 to 24. So how we do it? How do we do it? Well, basically, let's do it. Let's write the code. So the first we define a class, and this class is going to be the class of our environment. The reason we do class, because when we have a class rather than a function, of course you can do function, but if you have a class, you can define many environments without having to recode or to specify all the variables and methods. So if you want to create room number 1, number 2, room number 3, you just need to call that class to say room number 1 equals that class, and room number 2 equals to that class. You don't really need to define the values, and everything will be initialized, and the values in which related to the room will be initialized. So you can create any room you want. So it's better to use classes. So and it's a good practice for us to actually use classes rather than the more easy method, which is the function. So here we build a class with air conditioner and of course environment, and here we want to pass env env here. So basically we want to pass the environment in here, which is from the OpenAI gem library. The reason we do that, because we can use the methods in this environment. So rather than just having like a specific only the methods we define in this class. We can use also the methods related to this class as well. For example, if we want to close the environment, we just put this air conditioner dot close. We don't have to define how to close like all the environment, but by passing into here, we can use use these method taken from this library. So we define our environments. So we go for def init, and it will take itself, and here we will self dot action space equals discrete, and here it will be 3, because our actions is only will we say 0 is reducing the temperature, 1 is keeping the temperature the same, and 2 is increasing the temperature by 1. So this is how these things work. So now dot observation space equals box, and we have a low equals mp dot array. This is always a syntax we have to follow, and a high equals np dot again array 99. Now the reason why it's 99 is because if we put if we put from 0 to 100, that means it will make us a bit complexity in regarding the difference between the actual number of the state and the state itself as an ID. So in what we want to do is, now we have the temperature from 0 to 99. What we will do is we will take from 0 to 99 and we will assign it to an ID with the same number, which is in Python is from 0 to 199. It means 100 steps. So every actual temperature number will be corresponding to the ID number. Of course, if you want to put it the temperature from 0 to, let's say, or let's say from 1 to 100, that means you have to be careful to assign 1 means the ID of 0, and 2 will equals the ID of 1 in the state matrix, or what we will build as a Q matrix. The reason we do these things, because there is a difference between a state as the temperature, maybe a combination between temperature and pressure, or location XYZ, and the actual ID in the Q table. Because if you're building a 100, if you're considering 100 steps or 100 IDs, you have to correspond and connect it with the temperature or what XY on and so on. So this is a bit complex, but as you get to do this code, and as you gain experience with how to translate specific actions, or specific situations like the temperature, location, and so on, into an ID, things will become a little bit easier. So to make things easy from the beginning, we just say from 0 to 99, and the corresponding ID will be again from 0 to 99. So here the observation, now self dot state will equals 25 plus, this is going to randomly assign the space, the state, in case integer, -4 to 4. just when we reset the environment, the first time we create it, it will put the state as 25 and minus 4 to 4. This is always important to initialize these things, because the state is always very critical. So we'll have a beginning value, and then the state value will keep updated as we take actions. So this is, we just initialize it. Self dot control length equals 60. So we consider that our control length, the duration of the whole control length is 60. We can say 60 seconds, 60 minutes, 60 basically steps. This is, as a game, we'll have 60 steps, and then the game will reboot and we start again. So here we also define the step. Now, step will take all these numbers for whatever the environment is. So we write self, and it will take action. So every step, what will happen is we have a specific state, we take an action, increase the temperature, reduce the temperature, and keep it the same. This is all action. And then we will basically from that state, we will define our with the action, we will define what's going to happen in the next state. So here we just say the action is, if it's 0, this corresponding to reduction in temperature. If it's 1, it will correspond to no increase, no action, basically no action, nothing will happen. Or I don't want to use action, but no change is better to use rather than confuse action with this action. And if we have 2 is passed in this action, means we have increase in temperature. So here self dot state is very simple. Now the equation will equals plus equals action minus 1. So that means the state equals the state plus action minus 1, and if you pass 0, then it will be minus 1, so it will reduce the state by minus 1. If you put 1 minus 1 is 0, and then no change, it's the state will equal the state. And if you put 2, then the action will increase in number. So here also self dot control length, length, what will happen? It will reduce by 1. So of course control length equals control length minus 1, basically. Now, what else we have? We have the reward. If the self dot state is more than or equal than 24, and if also self dot state is less than or equal 26, that means everything is good. So you will get a reward of equals 1. What if you didn't get this thing? What you will have a reward of minus 1. It will be bad. So if self, so this is the just a quick thing, like a note. The reward, we can be 1 minus 1. That is, will be like a reward and penalty. You can also make it into any number, like it can be 100 or 1000, and the reward will be if you penalty minus whatever number it was. It can also be continuous, means like if the value is near 25, the reward will increase, and then as you go to the 26, the reward will become less and less. So it's like you can make it linear, something like this, like from 24 to 25, the reward keep increasing, and then it will go down from 25 to 26, and then it will become minus. It's also possible. You can write, there is no, you can write equation, you can write whatever you want. But in here, just make it simple. 1 plus minus 1. Self is state, or not state now, the control. So we want to make sure that we have, we signal that if the state become, if we were in 60, the length of the episodes, we already in 60, so we need to signal that it is done. So this is the length is less than or equal 0. If self control length, then done will equals true. If not, else done equals false. So we signal back that we finished. We can also send some info if we want. Just any info you want to, you can write it here. Now return self dot state and reward, and what we need is the done state, and of course the info whatever you want. Now usually we have also def render and self. If you want to render something, like plot something or output some graph or save some graph, you just put it here as like as a information, or like as a code you want here. In our case, we don't have really anything to render, just the temperature, so we will output as a print out the temperature, and that's it. Reset. Now this is important because after we define the actual environment, we need to reset it every episode. So we played one game and we finished, and then what we have to do, we have to reset. So what do we need to do in reset? The first thing is we need to initialize the state. So become self dot state equals 25 plus random dot rand integer from -3 to 3. Of course, you can do it anything you want, and then self dot control roll. What will happen? Control length, sorry, length will 60, will be equal 60, and return self dot state. Yeah. So basically, every time we reset the environment, it will reset the control length for the whole class, the whole object of that class, and then we also reset the state, 25 plus minus 3, and of course randomly, and then we return the state itself. With that, we basically finished, and we shift enter and hope there is no error. And we have an error. So here, let's see what is the problem. Is initialize. We need just a space here, and now it's running. So we want to create the environment, and in order to create the environment, we simply write inf equals, just we call it And of course, we don't want to pass anything here. If we want to pass, we can just write it here, and it already will pass in as a default. So env air conditioner, this is it. We create the environment and then we run it. And basically that's it. Of course, there are some warning messages, but no need, like we don't have to care about. Like we tested this and I didn't have any problem.